Welcome to this lesson. We're going to take a look at graphs of inequalities. So we're going to start with getting inequalities from graphs. So we'll be given graphs, then our job will be to create inequalities that describe a given region on a graph. Then in the next video, we're going to take a look at graphing from inequalities. What if you have been given inequalities? How do you come up with graphs? So when we do that, then we'll be done with this topic. There are two skills that are needed for you to find this easy. The first one comes from inequalities themselves, which is a topic we did. So just need basic knowledge of inequalities. Then the second one is coordinate geometry. You need to revise if you have forgotten on how to come up with the equation of a straight line. Let's get started. So we're going to learn through an example. There's nothing new here. It's just the application of the knowledge that we know. So in the diagram below, point A is 1, 1. So this point here is 1, 1. B is 0, 7. The point here, B is 0, 7. C is 14, 0. C here is 14, 0. D is 7, 0. D here is 7, 0. And E it's here, it's 7, 1. The question says, write the four inequalities that define the unshaded region R. So they want four inequalities that define this region here, the unshaded region R. So what does unshaded mean? So if you look here, there are two things you have to notice. The first is we have lines that have shadings. So for example, this line here has this part shaded and this part is not shaded. And this other line here has this part shaded and this part not shaded. So this R, it is surrounded by lines that are shaded on the other side, not on the side where R is. So all these four lines have the shading on the opposite, not on the side where R is. That's the first thing to note. The second thing to note is there are two types of lines. The first ones are like this one, which is a solid line, and this one also is a solid line. Then the other type of line is this one, which is a dotted line. So this one and this one are dotted lines. So there are two types of lines, solid lines and dotted lines. We're going to learn what they represent. So let's see, what's the first thing we are going to do? So step 1, to find the four inequalities that represent the region R, the first step is you choose one line and pick any two known points on the line. So what we're trying to do is to come up with the equation of a line. So we're going to apply coordinate geometry. So if you look at this line, we're going to choose this one. I'll choose this one which passes through A and E. So if we choose this one, we're going to use A and E as the point to use to develop the equation of a line. So A is 1, 1, E is 7, 1. So how do we come up with the equation of a line? The first thing is you need to remember the standard equation of a straight line. So this is step 2. The standard equation of the straight line is given by y is equal to mx plus c, where m is the gradient and c is the y-intercept. Y-intercept means the point at which the line crosses the y-axis. So this understanding is going to make things simple. With that in mind, let's first find m, the gradient. So we're going to use these 2 points. So remember, the formula for gradient is this y2 minus y1 over x2 minus x1. I won't explain what y2 and y1 are because I expect you still remember. But anyway, for those who don't remember, you just have to name these points like x1, y1, x2, y2. So y2 is this one, y1 is this one. So you plug in here y2 minus y1, which is 1 minus 1, and x2 is this one, and x1 is this one. So you plug in here 7 minus 1 is going to be 6. So we're going to have this 1 minus 1 and 7 minus 1. 1 minus 1 is 0, 7 minus 1 is 6. 0 divided by 6 is 0. So that is the gradient of this line. The third step is to replace m in y is equal to mx plus c. So you have to, this m that you have found, you put it here. What you're trying to come up with is just the equation of a straight line. If you know the equation of the straight line, then how to get the equation of the straight line, then you can even skip this part. But anyway, let's continue. So replace m in y is equal to mx plus c. So m is 0. When we do that, we're going to have this y is equal to 0 times x plus c. The dot in mathematics, at times, if you're fast, it represents a multiplication. So this is 0 times x plus c. So 0 times x, of course, is 0. So you can write this as y is equal to c. But for the sake of learning, I'm not going to do that because it's not always that you're going to have m equal to 0. So we'll go to step 4. Step 4, use either of the 2 points, A or E, to find the value of C. So I'm going to choose A. So use one of the points to find the value of C. To develop the equation of a straight line, you need the value of M and C. That's all. So we have got this equation, y is equal to 0 times x plus c. So we're going to plug in the points here. This is x, this is y. So if you put y here and x here, we should be able to get c. So doing that, we're going to have this 0 times 1 here, it's 0. So in short, we have 1 being equal to c. This is our c. So we can plug in c into here, which is step 5. Replace c into the equation of the line. So when you do that, you're going to have this. So y is equal to 0 times x plus c. 0 times x, we know it's 0. C, it's 1. So this is the equation of our line. So this line is described by this equation, y is equal to 1. That is actually the first important step. I've divided the step into 4 different steps just for revision, but this is the first step you do. You have to be quick with this one. Now, there is a secret that I'm going to share with you, and that secret is something that's going to help you save time when you're solving these kinds of questions. So when you're given a graph and you're expected to come up with the equation of the lines or to define the 4 inequalities or the 3 inequalities at times, what you have to start with is, if there are these lines, horizontal lines and vertical lines, first find the equations of the horizontal and vertical lines because they are simple to find. So how are they simple? Are they simple like the way I've demonstrated? No. There's nothing like using the formulas and the likes. For horizontal lines, here is the truth that holds. Any horizontal line has an equation of y is equal to c, where c is y-intercept. So any horizontal line has this equation, y is equal to c. C is where it cuts the y-axis. So this horizontal line, so horizontal line is any line that is parallel to the x-axis. So this horizontal line cuts the y-axis here. So the point it cuts the y-axis is what you're going to put here, and that's your equation. So in our case here, this point is 1, 1, meaning that the y value is 1, which means if you go to the y-axis, this point is 1. So in short, this point is just 1, and it cuts the y-axis at 1. So the equation of this line, of this horizontal line which cuts the y-axis at 1, is just y is equal to 1. You are done. No need to find the gradient. No need to come up with the equation of a straight line. It's going to give you the same answer. As you can see, here it's y is equal to 1, and here it's y is equal to 1. Then the other secret is vertical lines. So vertical lines are also simple to get the equation. And the secret is, any vertical line has the equation x is equal to x-intercept. So for any vertical line, or a line that is parallel to the y-axis, the equation of this line is just x equals to where it cuts the x-axis. If it cuts the x-axis at 7, then it's going to be x equal to 7. If it cuts the x-axis at 10, then it's going to be x equal to 10. If it cuts the x-axis at -1, then it's going to be x equal to -1. And if it cuts the x-axis at 5, then it's going to be x is equal to 5. So depending on where it's cutting the x-axis, that's how the equation will be. X is equal to 5 as long as it is a vertical line. So always start with horizontal and vertical line. It means you have solved 2. Then now you go to the other 2 lines if they are 4, or the third line if they are 3. If there are 3 lines that you need to develop the inequalities for. So step 6, we continue with our first line, this one. So on step 5, we found the equation of this. But we're not done. So go to step 6. Step 6, replace the equation symbol with appropriate inequality. So we are trying to come up with the inequalities, not the equation. So we don't need the equal sign. So this is y is equal to 1. This is an equation, but we want an inequality. It should have less than or greater than or less or equal to or greater or equal to. That's what we want here. So how do we choose which one is suitable here? So here is some knowledge. So there are two types of lines here. Like I said earlier, there is these ones which are dotted and these ones which are solid. So I'll take you back to inequations and number lines, how we are representing inequalities on a number line. So there were two types of circles that we were using when trying to represent an inequality on a number line. There was an open circle, which here it will be represented by dotted lines, and there was a solid circle, which here it will be represented by a solid line. So in short, the dotted line shows exclusion, which is less than or greater than. So wherever there's a dotted line, it means it is representing this symbol or this symbol, and this means exclusion, which means the points where this is passing should not be included in the discussion. So the points are excluded. Then the solid line represents inclusion, which are these two symbols, less or equal to or greater or equal to. So this is what the lines mean. So that's the first thing you need to know. The other thing is the shading. The shading is going to help you choose between these two or these two. Okay, so the type of line is going to help you know if it's these two or these two, or the type of line is going to help you choose if it's these two or these two. Then the type of shading, or where it has been shaded, is going to tell you which among these two or which among these two, as you are going to see. So actually our final answer is going to be y is greater or equal to 1. But how? So we're going to go to our line, this one here. We see it is a dotted, it is a solid line. So a solid line means it is either this one or this one, because solid means inclusion and means less or equal to or greater or equal to. So the next job is to choose which is it, this one or this one. How do we tell? So we look at our region. So our region is on this side of the line, not on this side. So we ask ourselves, is our region greater than the other side, or is our region less than the other side? So if you look at this part, at this line, it has the two regions, this and this, one can be greater than the other. How do we tell if it's greater? We look at numbers that, for example, for horizontal and vertical, it's simple. You just use the y-axis. You ask yourself, are these numbers here greater than the numbers here? So the region of interest is this part. So if you look at this side, we have numbers like this is 1. So here maybe we have 2, 3, 4, just like that. And down here we have -0, -1, -2. So numbers here are greater than the numbers here. Therefore, this part is greater than this part, and y is greater than or equal to 1. So that's the symbol used. Y is greater or equal to 1, because the region of interest is on the upper part, not on the bottom part. So this is how to deal with choosing the appropriate inequality. Now let's take a look at the other lines. So step 7, repeat the above steps for the other lines. So you do the same for the other lines, but for vertical and horizontal line, we don't have to do all this. We just write the equation. So we are going to choose the vertical line, so we understand how simple this should be. So this line here, the vertical line here, is going to be the next one. So choosing the line that passes through E and D. So this is E and D. So we're talking about this vertical line here. So we have got 2 points representing, or that are 2 known points that are on this line. E, which is 7,1, and D, which is 7,0. With that in mind, since it's a vertical line, we're going to do the secret that I just told you. So we're just interested on where does it cross the x-axis. So if this point is 7,1, the x value here is 7, meaning that if we go down here, this is 7. Even D itself is 7,0. D is actually the point where the line crosses the x-axis. So the x value is 7, meaning that this point is 7. Therefore, the equation of this vertical line is x is equal to 7. The next thing is choose the appropriate inequality. So first we look at this. This is a it is a dotted line. Because it is a dotted line, so we're going to use less than or equal to. Sorry, you're going to use less than or greater than. For dotted lines, we use less than or greater than. So once we identify the set of inequalities that we're going to use, the next is to look at the shading. So it is shaded this direction. So if we look here, if we look at this direction, we ask ourselves, the region of interest is this side. So is this side greater than this side? So just by looking, you can tell that this side is less than this side. How? If you use the x-axis as the number line, you can see that numbers here are greater than numbers here. This is 7, so this must be 8, 9, just like that. And going this direction, we're going to have 6, 5. So numbers on the side the region is less than this, the numbers here. So our inequality is going to be x less than 7. So there's no equal to here because it's dotted, and it's less here because the region seems to be on the lesser side as compared to the shaded region. So we have dealt with the two simplest. Even the first one, these are the steps, even the first one, but I wanted to teach you how to tackle a normal one. So let's go to the normal ones, which are not horizontal, vertical ones. So go to the line that passes through B and C. So B and C, we're talking about from here to here. So we're talking about this line here. So the first thing is to identify the 2 points on the line, and the points are 0, 7 and 14, 0. Again, we recall the equation of a straight line, y is equal to mx plus c. We find m, and we're going to have -1/2. I'm not going to show you this because I've explained in the first one, and I'm sure you know how to do this. We did this in coordinate geometry. So m is equal to -1/2, and we're going to replace m in the standard equation of a straight line, which is y is equal to -half x plus c. Then from there, we need to find c. We use n of the points. So choosing the points, I advise you choose points that that don't have negative signs, or points that have zeros, or points that have small numbers. They are easy to calculate. You won't be making mistakes. So here, since it seems like we have a fair share of points, we have 0, 7 and 14, I'm going to choose 0, 7. So I'm going to replace these numbers. I'm going to plug them in this. So plugging them in, we're going to have this y, we've put it here, and x, which is 0, we've put it here. So when we solve this, we're going to have 7 as c. And our equation is going to be y is equal to -half x plus 7. Another secret. So when you solve, you find the gradient, you put it here. C is easier to find if you can tell where the line cuts the y-intercept. Remember, C is y-intercept. So for this line, instead of doing this part, this process here, you can just look. If you can see the value where it cuts the y-axis, you can just put that value here. So in this case, B is B. If you go here 0, 7, the y value is 7. So this point B, it is 7. So the y-intercept, the point at which it cuts the y-axis, is at 7. So C, you can just put 7 here without even doing the mathematics here. So when you reach here, you just write y is equal to -half x plus 7, because 7 is where it cuts the y-axis. That's a secret. But if you want, you can just go the conventional way. You plug in, you solve, and you have this. But the first test is just to look. So the next is to determine the appropriate inequality. So if you look at this line, it's a solid line, and this side is shaded. So for a solid line, we use greater than or equal to, or less than or equal to. That's what we use for solid lines, to show inclusion, to mean this part has been included. This knowledge of inclusion and exclusion is going to become very useful when we're dealing with linear programming. So now that we have identified the possible two inequalities that we can use on this, the next is the shading. So this part is shaded. So if you look at this part is shaded. The region is here. Again, by looking, I can say this part is less than this part here. But for for those who are doubting Thomas's, what we're going to do is we're going to use this scale to test what inequality is appropriate here. So what we do is, on the side where the region of interest is, pick any point on this side. So I'll pick point A, which is 1, 1. So when you do that, you get this equation, you put the values 1, 1, and you compare this side, you see which one is going to be bigger. So I've plugged in 1 here, and the x1 I've put here. So this side I'm just going to have 1. This side, -half times 1 plus 7, if you have a calculator, because this should be a rough work. You do it somewhere, it's not something that the examiner is interested. So you can do it somewhere, you can get your calculator, you just punch here if it's paper 2, and you're going to have 13/2 this side, or 6.5. So you ask yourself, which side is greater, 1 or 6.5? 6.5 is greater. So here, the appropriate symbol that should be here is 1 is less than 6.5, because this side is great and 1 is less. So you're going to say 1 is less than 6.5. And that's the appropriate inequality you're going to put here. So so y is less than -half x plus 7. Y is less or equal to -half x plus 7, because it is solid, and this shows less than according to our analysis here. So this is the analysis that you should always be using. You get the side of interest, then once you get any point on the side of interest, you just plug in, then you compare the side, then you just when you see which side is greater or less, you use the appropriate inequality, and then you use this in the here, so that you have the final answer here. So this is the inequality. Finally, we're going to take to develop the equation for this line, the inequality for this line. So choosing the line that passes through A and O. So we're choosing the line that passes through O here and A. So we're talking about this. We have A, it's 1, 1. O we have not been given here, but O is something that you should know. The coordinates of O are 0, 0 always. So our origin here, it's 0, 0. So I'm going to use these 2 points. So y is equal to mx plus m is the gradient, and when we plug in the values, I'm not going to explain, we're going to get 1, and we're going to have y is equal to 1 times x plus c. Our job is to find c. So how do we get c? So we get c by using any of the 2 points. In this case, I've got 0, so I'm going to use 0, 0. So y is equal to 1 times x plus c, just the same as y is equal to x plus c. So if I plug in 0, 0, I'm going to have 0 here and 0 here plus c, and our c is going to be 0, meaning that the equation of our line is y is equal to x. This is another secret. This is our third secret, I guess. Yes. So for any line that passes through through the origin, the equation is usually it has c is equal to 0. Anyway, the y-intercept is where it passes the y-intercept is where the line cuts the y-axis. So it cuts the y-axis at 0. So again, this part you cannot solve like I explained earlier. So you can, from here, you can just put 0 here, and you're going to have y is equal to x. With that in mind, the last part is we choose the appropriate inequality here. So how do we do that? Again, we look at our line. So we know that it is dotted, which means we're going to use greater than or equal, greater than or less than. But let's use the analysis like we did before. So this is our line, it's dotted, we're going to use greater than or less than, one of them. So again, the region is this side. Is this side greater or less than this side? So again, for those who have eyes, they can see, but here I won't use my eyes. I want to use the analysis like we did before. So on a rough paper, this is what you can do. So you pick any point that is on the same side as our region. In this case, I'll pick E. E is 7, 1. I couldn't pick A because I did not pick A because this is where the line is passing. I want the point that is on the same side, like this region, E, D, or anything. So E is 7, 1. So I'm going to plug in here. So y it's 1 and x is 7. So if I look at 1 and 7, of course I need to replace this. I can't use equal here because they are not equal. So which inequality can I use here? So 1 is less than 7. So this is the appropriate inequality. 1 is less than 7. And the fact that it is dotted, so it's going to remain like this. If it was solid, then I was supposed to put equal here. So mean that this is supposed to be y is less than x. So this is our last inequality. So this marks the end of this topic. The next topic is going to be, the next part of this topic is going to be very short, and it's just the opposite to what we've been doing here, and that is coming up with drawing this if you have been given inequalities. Hope you have enjoyed, and I know it's a lot to take in. If you do 2 or 3 questions, you become used and you see how simple it is. You just have to be fast and maybe adapt some of my secrets. Otherwise, happy solving.